Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss exercise 13.1 question number 11 to 17 of M.L.Aggarwal Class 9 Mathematics. If you like this video, please like, share and subscribe my channel. So let's start solving this exercise.
Solve here 11th first part. We have to prove that the bisectors of two adjacent angles of a parallelogram are at right angles. Firstly, let it be parallelogram be ABCD here, and AM is the bisector and BM is the bisector of angle B. So as we have that AD is parallel to BC and this AB is a transversal, we can say the adjacent angle sum is equal to 180 degree, means angle A plus angle B is equal to 180 degree, as they are adjacent angles in a parallelogram. Now, as the angle A plus angle B is equal to 180 degree, we can just multiply it with half. So, half of angle A plus angle B is equal to 90 here. So, simply we can write this as half of angle A plus half of angle B is equal to 90 degree on writing it. And as we have now angle AMB, because now we have to find that AMB, that we have to prove that this AMB is a right angle, means 90 degree. So simply we can write in triangle AMB, angle MAB plus angle MBA plus angle AMB is equal to 180 degree, as this is a triangle. And now we can write this MAB because this is half of angle A here. So half of angle A is the bisector here and half of angle B is also the bisector, and its sum is equal to 90 degree. So similarly this we can write it as half of angle A plus half of angle B plus this as this part, and this is angle AMB which we have to find. Now we can simply put the value of here half angle A plus half angle B. On putting it, we can write it as 90 degree plus angle AMB. Now we can simply find the value of angle AMB from here. So this AMB is equal to 180 degree minus 90 degree. This is only we have to prove that the bisectors of two adjacent angles of a parallelogram are at right angle, means in 90 degree. Hence proved from here. Now let us solve 11 second part here. We have to prove that bisectors of any two opposite angle of a parallelogram are parallel. Simply this is the parallelogram here ABCD, and let the bisector of A as AR and let the bisector of C angle C as CQ. Here we can simply write, because in a parallelogram opposite sides are equal, so angle A is equal to angle C. We have to prove that this bisectors means AR is parallel to CQ. As angle A is equal to angle C, we can say that opposite angles of a parallelogram are equal. So from that information we can write this part, and as here this angle we can just multiply it with half. On multiplying we will get to find the angle here. So this will be half angle C from here, and simply we can write this half angle as DAR. So angle D, from this information angle DAR is equal to angle BCQ. So this is equal to BCQ here, because this is the bisector here. ACAR is the bisector, means angle DAR is equal to angle RAQ. Similarly we can write this part. And now the second thing which is here, this angle AD is equal to angle CB, because in a parallelogram opposite sides are also equal, means DA is equal to BC here, because opposite sides are equal. So this is here opposite sides are equal. As these opposite sides are equal, we have this angle D is equal to angle B also, because this is also the opposite angles here. So because they are opposite angles, now we can simply prove that in triangle DAR and triangle QCB. We have these both triangles as congruent from these given three information which we have proved here. Triangle DAR is congruent to triangle QCB from here. Now, as AB is parallel to DC here in a parallelogram, so we can say that DAR and this DRA is equal to RAQ. So from here we can simply write, let us write here, that angle DRA is equal to angle RAQ, as they are alternate angles. So this is alternate angles. Now, the second thing we can write from here, that DRA is equal to CQB, as CPCT here in these both triangles. So again we can write it as angle DRA is equal to angle B BQC. As this is also angle DRA and this is also DRA, means these both angles are equal from here. Hence angle RAQ, um, sorry, this is here angle, so it is right only, angle RAQ is equal to angle BQC. So this is only we have to prove, as if angle RAQ here is equal to angle BQC, means this is a these are corresponding angles. So these are corresponding angles from here we can write, and as these are corresponding angles, we can simply say that AR is parallel to QC. So AR is parallel to QC here, hence proved from here only. So we can write here that AR AR is parallel to QC. This is only we have to prove in this question, hence proved. Let us solve 11th third part. If the diagonals of a quadrilateral are equal and bisect each other at right angles, then prove that it is a square. So, firstly, we will take, to prove that it is a square, we will take the triangle here AOB and OCD. As it is given that they bisect each other, these diagonals at right angles, means OA is equal to OC and OD is equal to OB. This is given to us, and from that part only we can say that these two are vertical angles, means angle DOC is equal to angle OAB, because these are vertical opposite angles. So now if this is the thing, we can simply say that these two triangles are congruent from these three things by side angle congruency. Side congruency means triangle OAB is equal to triangle ODC by side rule of congruency. We have proved that. Now from this part only we can prove that AB is equal to DC here by CPCT, and if these sides are equal, and we can again write that OCD is equal to angle OAB by CPCT. OCD is equal to angle OAB by CPCT, and as these are angles who are alternate also, so we can simply say that these are alternate angles also, and from that we can conclude that side AB is parallel to side CD, and now as this is parallel, we can say that in a parallelogram, diagonals are equal and bisect each other. So if in parallelogram diagonals are equal and bisect each other, so from here only we can say that if this is a parallelogram, this is a square also. From this part we can say AB is equal to DC here and AB is parallel to CD. Means this parallelogram ABCD is a square. Hence proved. This is only we have to prove in this question, so proved. Now let us solve question number 12, first part. If ABCD is a rectangle in which the diagonal BD bisects angle B, then show that ABCD is a square. From here simply we can see that if a BD bisects angle B, then it will bisect angle D also, because opposite angles are equal in a parallelogram and rectangle is a parallelogram. So simply we have angle B is equal to angle D. And here BD bisects, because BD bisects angle B and angle D. And from here only we can say that angle 1 is equal to angle 2, because in a rectangle the angle between angle of ABC here it is 90 degree. So simply we can say angle B is equal to angle D, which is 90 degree. And from here we can write angle 1 is equal to angle 2 and angle 3 is equal to angle 4. And here angle 2, angle 1 and angle 3 we can say that it is equal to 90 degree, 45 degree, because diagonal BD bisects the angle B. And here here angle 1 is equal to angle 3, the opposite sides of equal angles are also equal. From that we can prove AB is equal to AD here. And as we know, in a rectangle we have the opposite sides as equal. So we can simply write here AB is equal to DC here. Opposite sides of a rectangle are equal. So here it is equal. Again we have AD is equal to BC here. So AD is equal to BC. So we can simply write from here only that AB is equal to BC. Simply here AB is equal to BC. BC is equal to CD here, and CD is equal to DA. So this, if this is proved, we can simply say that it is a square here. Hence ABCD is a square. Hence proved. So this is only we have to prove in this question. Let us solve question number 12, second part. Show that if the diagonals of a quadrilateral are equal and bisect each other at right angles, then it is a square. So here the given information is this, that the diagonals of a quadrilateral bisect each other and are equal. So from here we can say that OA is equal to OC here, and OB is equal to OD also. But here OB is common in this triangle ACB. So here OB is equal to OB. This is common, and the angle AOB and COB are also equal. So here we are taking triangle in triangle AOB and triangle COB. AO is equal to OC, OB is common here, and angle AOB is equal to angle COB, because each are 90 degree, each are of 90 degree here. So we can prove that a triangle AOB is congruent to triangle COB by SAS rule of congruency, side angle side rule of congruency. So this is side angle side rule of congruency. We have proved this, and from here by CPCT we can prove that AB is equal to BC. So AB is equal to BC here by CPCT, and again we can take the triangle here DOC and COB. So here in triangle DOC and triangle COB, again similarly we can prove that by the same process which we have proved in the previous one, that CB is equal to CD, and similarly again in triangle AOD and triangle DOC we have here AD is equal to DC. So AD is equal to DC. From these three information, first, second and third, we can prove that AB is equal to BC, BC is equal to CD, and CD is equal to DA. So we can write here AB is equal to BC, BC is equal to CD is equal to DA. And this is only we have to prove that, because all the sides of a quadrilateral are equal, means it is a square. Hence it is a square, which we have to prove in this question. Now let us solve 13 question. P and Q are points on opposite sides AD and BC of a parallelogram ABCD such that PQ passes through the point of intersection O of its diagonal AC and BD. Then show that PQ is bisected at O. From here we can simply say that OA is equal to OC and BO is equal to OD because these are diagonals. And now in triangle AOP and COQ, AO is equal to OC and angle OAP is equal to angle OCQ because these are alternate angles. And now we have POA and angle COQ as equal because these are vertically opposite angles. And simply we can prove that POA is equal to triangle COQ because by angle side angle rule of congruency, because this is a side and this is also angle, this is also angle. Now from here only which we have to prove that PQ is bisected at O, we can prove that by CPCT PO is equal to OQ, hence proved from here. Hence O bisects PQ. This is the final answer which we have to prove in this question. Now let us solve question number 14, first part. In figure given below, ABCD is a parallelogram and X is midpoint of BC. The line AX produced meet DC produced at Q. The parallelogram ABPQ is completed. Then we have to prove that the triangles ABX and QCX are congruent. Here we can simply say that X is midpoint of BC means BX is equal to XC because X is the midpoint here. X is the midpoint of BC, and from here only angle AXB is equal to angle CXQ because these are vertically opposite angle here. So these are vertically opposite angle. And the third thing is here angle XCQ is equal to angle XBA. So here also we can write as XCQ is equal to angle XBA as these are alternate angles because CQ means this line DP is parallel to AB. So these are alternate angles here. And from here only by angle side angle rule of congruency we can prove that triangle ABX is congruent to triangle QCX. This is only we have to prove. So by angle side angle rule of congruency we can prove this part. This is only we have to prove in the first part. And the second thing which we have to prove in this question is DC is equal to CQ is equal to QP. Here from this part we can simply conclude that this CQ is equal to AB by CPCT. So CQ is equal to AB by CPCT here. And the second thing is AB is equal to DC because it is a parallelogram. So AB is equal to DC. And the third thing is AB is equal to QP. So because it is also a parallelogram. And from these three things we can simply say that DC is equal to CQ. So from here with these three things it is DC is equal to CQ is equal to QP here. So this first, second and third we can prove, hence proved from here. Now let us solve question number 14, second part. In figure given below, points P and Q have been taken on opposite sides AB and CD respectively of a parallelogram ABCD such that AP is equal to CQ given to us, so that AC and PQ bisect each other. Means here we have to prove that OA is equal to OC and OP is equal to OQ. To prove this, we can simply say here in triangle AOP and triangle COQ, we can simply write AP is equal to CQ and angle AOP is equal to angle COQ. Vertically opposite angle, these are vertically opposite angle here, and angle OAP is equal to angle OCQ here. So these are alternate angles here. Now, in triangle AOP is equal to triangle COQ here. So, triangle AOP is congruent to triangle COQ by angle side rule of congruency. So hence we have proved here. And from this congruency only we can prove that OA is equal to OC, OA is equal to OC and OP is equal to OQ by CPCT. This is only we have to prove. So proved here that AC and PQ bisect each other at O. Hence proved. Now let us solve here 15 question where ABCD is a square, A is joined to a point P on BC and D is joined to a point Q on AB. If AP is equal to DQ here, then prove that AP and DQ are perpendicular to each other. So to prove this part, firstly we will take the triangle. In triangle ABP and triangle DAQ, so we can simply write here as it is given AP is equal to DQ and AD is equal to AB here because ABCD is a square. Because ABCD is a square, we can simply write this part here. And from there only DAQ is equal to ABP we can say, as both are of 90 degree because it is a square. So angle this is DAQ is equal to angle ABP. From there only we can prove that triangle ABP is congruent to triangle ADQ, as by right uh, right right angle hypotenuse side rule of congruency we can prove this part. And by this congruency only we can prove that BAP is equal to, means this BAP is equal to ADQ here. So by CPCT, so angle BAP is equal to angle ADQ by CPCT here. And again from that part only we can write angle BAD is equal to 90 degree, as we know that angle BAD is equal to 90 degree because this is a square. From this part only we can prove here that angle BAD is equal to the sum of angle BAP plus angle PAD. So from that part, and BAD is equal to 90 degree, we will put the value here, and this BAP plus angle PAD. And as we know, we have previously proved that from the first equation here, we will put here BAP is equal to ADQ, means angle ADQ plus angle PAD plus angle PAD is equal to 90 degree here. And again we will take the triangle here. And third part, in triangle ADM, here this triangle ADM, we can simply write, we have proved here that ADQ, this ADQ we can write it as angle ADM, means angle ADM plus angle PAD, this is PAD, so it will be MAD, we can write angle MAD plus angle DMA is equal to 180 degree here. So we will put the value as ADQ plus PAD as 90 degrees. So 90 degree plus angle DMA is equal to 180 degree. And from that we can prove that angle DMA is equal to 90 degree. And we have to prove here that AP and DQ are perpendicular. So from here we can prove that DM is, from this part, angle DMA is equal to 90 degree here. Hence we can prove that this line DM is perpendicular to AP. So here we can write DM is perpendicular to AP, and from this DQ we can write, so DQ is equal, because DM and DQ are the same we can say. So DQ is perpendicular to here AP, and this is only we have to prove in this question. Hence proved from here. We have to prove here that AP and DQ are perpendicular, means DQ and AP are perpendicular from this part. Let us solve question number 16 here. If P and Q are points of trisection of the diagonal BD of a parallelogram ABCD, we have to prove that CQ is parallel to AB. Simply, as P and Q are trisection, we can write BP is equal to PQ is equal to QD. This is given to us here in this question. And here AB is equal to DC because it is a parallelogram. Firstly, we can prove in triangle APB and triangle DQC. So here we have AB is equal to CD. because ABCD is a parallelogram and opposite sides of a parallelogram are equal. The second part which we can write is angle ABP is equal to angle CDQ. So angle ABP is equal to angle CDQ because these are alternate angles here, and as these are alternate angles, again we have here this part BP is equal to QD because this is given to us. So BP is equal to QD here. From there only we can prove that triangle APB is congruent to triangle DQC by side angle side rule of congruency. So this is side angle side rule of congruency. We can prove this part. And from this part only we can write that this AP is equal to QC. So here AP is equal to QC by CPCT, and angle APB is equal to angle C CQD. This is also by CPCT, and we can write this as here minus, we can multiply it with minus, so this will be APB equal to angle CQD only. And from this we can write it 180 degree. We can just adding 180 degree on both sides, it will be 180 degree. Firstly here we have multiplied with minus, so multiplying both sides by minus, we can write this as this part only by taking minus this side. So both sides by -1, and here 180 degree minus angle APB is equal to 180 degree minus angle CQD. So adding 180 degree on both sides. Now, because here we have added this 180 degree on both sides, we can simply write this as 180 degree minus angle APB as angle APQ here. So this will be APB and minus 180 degree will be APQ. So here APQ is equal to 180 degree minus CQD. That will be CQP from here. So angle CPQ here, as these both angle are equal and these both sides are equal, AP is equal to QC, we can write here that AP is parallel to QC here because these are alternate angles also. So because they are alternate angles, we can simply write this as AP is parallel to QC. So this is only we have to prove in this question, hence proved from here. Now let us solve question number 17. A transversal cuts two parallel lines at A and B. The two interior angles at A are bisected, and so are the two interior angles at B. The four bisectors form a quadrilateral ACBD here. Then we have to prove that this ACBD is a rectangle and CD is parallel to the original parallel lines. So here, as it is given to us that LM is parallel to PQ, and angle, we can say that because this AC is a bisector of angle A, so this will be angle 1, this will be angle, we can write this as 2 also. So let it be this be 1, 2, and this be 3, and this be 4. And here also, because this is also a bisector, we can write it as 5, this angle be 6, and this angle be 7, again this angle be 8. So as LM is parallel to PQ, we can say that LAB means angle LAB plus angle BAM. Angle BAM is equal to 180 degree here. Now from here we can write half of angle LAB plus angle BAM is equal to 90 degree. And as we have just multiplied it with half, we can write this as this is also a bisector, as angle 2 plus angle 3 is equal to 90 degree, and the whole angle CAD from it is equal to 90 degree. Similarly we can prove for uh, angle here CBD, this is also 90 degree if we prove it similarly. And now in triangle ACB, we can say that angle 2 plus angle 6 plus angle C is equal to 180 degree because it is a triangle. So in triangle ACB, we can write angle 2 plus angle 6 plus angle C is equal to 180 degree, and angle C is equal to 90 degree, because angle 2 plus angle 6 will be 90 degree, as angle LAB plus angle ABP is equal to 180 degree. So angle LAB plus angle ABP is equal to 180 degree, and if we write this, we can write this angle LAB, half of that will be 2, and again half of ABD, we can write it angle 6. So this will be 90 degree on dividing it with half. Again, as 2 plus angle 6 is equal to 90 degree, hence angle C is equal to 90 degree. From this part only we can say that these two are congruent triangles, and for that we have this also as 90 degree and angle D also similarly 90 degree, because angle 3 plus 7, again it will be equal to 180 degree, and we will subtract that. Hence, the first thing which we have to prove, that ACBD is a rectangle. As we have proved that two angles are congruent, as these are alternate angle, angle 2 and angle 7. Angle 2 is equal to angle 7 and angle 3 is equal to angle 6 from here. And AB is equal to AB. So hence we can write here that triangle ACB is congruent to triangle here BAD, and from that only we can prove that AC is equal to BD, as in a rectangle AC is equal to BD and CB is equal to AD. So hence proved that ACBD is a rectangle in this question. Now the second thing which we have to prove is that this ACD is parallel to the original parallel lines. So this is also proved here. Now as we know that in a rectangle we have AO. Here AO is equal to OD, because in a rectangle diagonals are equal and they bisect each other. From that we can conclude that AO is equal to OD here, and as this is perpendicular, AOD is equal to 90 degree here, because if we add this 45 degree plus 45 degree, because this is also 90 degree, so from that only we can write as angle AOD is equal to 90 degree. Here AO is equal to OD. So from that we can say that this CD is perpendicular to AB. As CD is perpendicular to AB, hence CD is parallel to LM and PQ. So this is only we have to prove, hence proved from here.
Thank you for watching my video. If you like this video, please like, share and subscribe my channel.